Ah, the sounds of the holiday.
Ho, ho, ho.
Because when you open a College Savings Iowa account, you're giving a child the gift of education to help pay for college and trade schools. You get a tax break and peace of mind for whatever's ahead. Register before December 31st, and you could be one of 2 lucky winners to get $5,290. College Savings Iowa. Sounds like success. Visit collegesavingsiowa.com today. Administered by the State Treasurer of Iowa.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on yet another edition of Space Nuts. My name is Andrew Dunkley, and Fred Watson, as always, joins me to talk astronomy. Hello, Fred.
Hey, Andrew. Seems like no time at all since we did 155.
Funny that. Now, I love inside jokes. Today, we're going to be talking about a mini moon near Neptune, in fact. We're also going to look at that issue of heavy water, which stems from an episode we did a couple of weeks ago regarding how Earth's oceans may have come into being, perhaps water deposited by asteroids. But we learnt during that particular discussion that there's more than one kind of water out there, and it was possible that heavy water may have ended up on Earth instead of standard water. And it prompted a question in my mind as to what our planet might be like if it was covered in heavy water and whether or not we would survive in such an environment. So we'll look into that and we'll answer some questions about whether or not wormholes exist and could we travel through them, and a question about the dark matter halo and the effect on time. Great questions coming up soon. But first, the mini moon of Neptune. Interesting.
Yeah, it's a story that has its origins in basically astronomers surveying the outer solar system, and in fact it was a Hubble telescope image that first alerted scientists actually based in the United States to the possibility that there's another moon of Neptune. Now, I've lost count of how many moons Neptune has. When I was a kid, it had 4, I think, or something like that, a very small number. But now it's more because, of course, back in the 1970s, the Voyager spacecraft, I think it was Voyager 2, flew by Neptune and sent back images of that world. That's the only time Neptune has been visited. The 2 outer planets, Uranus and Neptune, are the least well-studied of all the bodies in the solar system, all the large bodies in the solar system.
I think anyway, officially it has 14.
Thank you. There you are. There you are. So it's grown a bit since my time. But it's got another one. And it's a tiny object. I mean, given how far away Neptune is, its distance is measured in billions of kilometers. It's something like 4 or 5 billion kilometers. I can't remember the exact number from the sun. But this object is about 30 kilometers across. So, it's not bad going to detect it. That means it's very faint.
Yeah.
And it was, as I said, it was on a Hubble telescope image that it was first noticed. But then what you've got to do is confirm it. And that confirmation has taken quite a long time because you need to observe something like that very carefully. First of all, to ensure it's really there, and secondly, to try and deduce what its orbit is like. So how do you find if it's really there when it's only just tickling the electrons on your detector when you take an image of it? So what you do is you take repeated images. This is a common technique in astronomy where you're trying to observe very faint things. You take multiple images of it and stack them one on top of the other. So you add together digitally the pixel values for each image, and that will bring out anything that is very faint. It will tend to enhance the contrast, especially if you do it in clever ways. But the problem is, if you do that with something that's moving through space, then just stacking a whole pile of images is going to give you, it's not going to gain you anything, because each new image of the object will fall in a different place because it's moving.
Yeah.
So what you have to do is take a guess as to what its motion is, and then shift the images when you add them so that you're stacking in a kind of motion compensated way. This is a bit technical, but what it does is it results in a much greater sensitivity, and that is exactly how this little world has been discovered. They took something like 8 5-minute exposures and then shifted them so that they didn't smear out the orbital motion of this little moon, and it's there. They've got it, and it's now been formally named by the International Astronomical Union. In the Neptunian system, the moons are conventionally named after sea creatures, as you'd expect, because Neptune's the god of the sea, and gods from Greek and Roman mythology. And so this one is called Hippocamp. It's actually the name of that monster. You might have seen a kind of horse-like, fish-like monster that often pulls Neptune's chariot in depictions of the way these gods go around the heavens. If you look at things like that, that creature is called Hippocamp, and that is now the name of this moon.
Yeah, I'm just looking through them now. There's some fabulous names: Triton, Proteus, Despina, Galatea. Hippocamp's actually in that 14 that I found. So they've already catalogued it. Mm.
Yeah. It's actually Hippocamp orbits just inside the orbit of Proteus. Proteus is a much bigger object. It's 10 times the size of Hippocamp, something like 350 kilometers across. With some interesting aspects, it's actually got a big crater on it that must have been caused by an impact at some time.
Yeah, and some of these moons aren't really all that spherical either, are they?
No, they're not, and Hippocamp won't be either. It's too small to be spherical.
And I understand it's also a very fast object in comparison to the orbit of our moon.
Yes, that's right. So its speed is about 10 kilometers per second in orbit. That's actually, in absolute terms, it's not that fast. When any spacecraft goes into orbit around the Earth, it's traveling at usually about 8 kilometers per second. But our moon orbits at 1 kilometer per second. So it's much faster than the orbital speed of our moon. And of course, the way orbit dynamics work, the closer you get to your parent body and the bigger your parent body is, the faster you have to orbit. And that's why Hippocamp is orbiting very quickly around the planet Neptune.
Okay, and there's probably more to discover out there because we're finding stuff all the time, and these gas giants of ours keep throwing up all these oddities and new discoveries. It's even in our own backyard, despite the fact we've got technology that can take us into vastly distant parts of the universe, we're still finding amazing things in our own backyard, which I think is just fabulous.
Yeah, indeed.
Okay, you're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and teeing with a go.
Space Nuts.
Now, Fred, to a question that came to my mind a couple of weeks ago when we were talking about how Earth may have received all its water. And this stems from the possibility that new evidence may have been discovered that shows that Earth's water was provided by asteroids. And it got us onto the topic of the kinds of water that are floating around in space, one of which is heavy water, which prompted a thought in my mind: what if Earth was actually filled up with heavy water instead of standard water as we have now, and is obviously the thing most necessary to maintain life on this planet, amongst other things, but it's, probably the most important thing. It got us to thinking about heavy water, and what if Earth was predominantly covered in heavy water? What impact would that have on life here? Could we survive? Would we exist today? So why don't we look into that a bit and see where it leads us?
Indeed, we did. So just to recap, it was actually comets, not asteroids, that are thought to have brought the water to Earth. But the problem is that comets have a different mix of heavy water and normal water to what the Earth's oceans do. And that's been a problem for people who suspect that comets provided the Earth's oceans. But the discovery we reported a couple of weeks ago was about what are called hyperactive comets, which seem to have the same blend of heavy water and normal water that the Earth's oceans have. And so maybe the idea that the oceans came from comets is still viable. But yes, exactly as you said, we thought outside the box, as we often do, and wondered about whether heavy water is something that you can actually live in. I think had the Earth's oceans been mostly heavy water, we would have evolved to be creatures that used heavy water as our working fluid. We'd be slightly heavier, of course, because it actually weighs more. But we would have been okay, because the first thing about heavy water to note is that it's not radioactive. What is it? Let me just recap what it is. It's the same stuff as normal water, H2O, 2 hydrogen atoms and 1 oxygen atom, except with heavy water, either one or both of the 2 hydrogen atoms is what's known as deuterium. It's an isotope of hydrogen that has an extra neutron. And it's that extra neutron that gives it the extra mass and makes it different from normal water. So this is the heavier isotope of hydrogen that we're using. So, so imagine we as earthly beings who've evolved on the planet as it is now, what if we were confronted with large amounts of heavy water?
Yeah.
What's going to happen? Well, we won't get fried, as I said, because it's not radioactive. And actually, you can drink it at some level. You can't drink much because of there are some subtleties in the way that heavy water forms molecular bonds with other molecules that will change because you know it's not normal water that you're drinking. So you clearly would be at risk if you started drinking huge amounts of heavy water. But you could drink certainly a glass of heavy water and you'd be okay. I can't say it's something I fancy doing. But,
No.
You know, it's nevertheless, it would be possible. But then if you said, all right, let's replace the normal water in your body, because of course we're something like 70 or 80% water, our bodies are made of. If you were replacing that with heavy water, where would be the critical point?
The point of no return.
And that's right. And apparently, reading up from learned websites, you could survive having 20% of your water replaced with heavy water. That you'd still live. But if you went much higher than that, there'd be significant effects. And if you replaced your water by 50% of heavy water, in other words, if half your bodily water was heavy water, you'd die.
Okay.
That would be the lethal dose. So it's not something that I would advise. There are other species, though, that are quite happy in heavy water, including some bacteria and actually algae as well. They don't
have a problem with it.
No, that's right.
I'm looking at an article now, and at 25% replacement, you become sterile.
That's right.
So, we would, if the planet had been seeded with heavy water from those comets rather than the water we know and love today, and mistreat, I might add, we would have to have adapted completely differently to be able to actually breed. So it's a really interesting scenario to consider. Most interesting indeed.
Yeah. So anyway, we've answered the question. It's not as dramatic as you might think to be confronted with heavy water.
And there must be heavy water that naturally occurred on Earth at some stage. It's just
yes, that's right.
But it's obviously just not in great bulk.
It's very, very rare. That's right. It's the amount is very small. In fact, I've got a figure here that says only about one water molecule in 20 million naturally contains deuterium, which is heavy hydrogen. So it's a rarity.
You said it's not radioactive, but interestingly, if you drink too much of it, you start to look like you're suffering radiation poisoning because it does damage the ability of the body to replicate DNA.
Yeah.
So you do have... There are issues in drinking too much.
There are issues, yeah. It's not advisable.
But, it's not going to kill you in minor doses. And as you said, I think last time we talked about it, you could swim in it. It wouldn't be a big problem. But, you don't want to really guzzle too much of the stuff. Does that mean there may be other kinds of water out there that we don't know about aside from this? I mean, this one's called D2O, isn't it? Isn't that it's...
Well, yeah, because they've used the D is sometimes the term used for heavy hydrogen, the hydrogen isotope, deuterium it stands for.
Right.
So deuterium is heavy hydrogen. Look, not really. You've got that suite of normal water or heavy water, basically, depending on just how much. Depending on the mass of the hydrogen atoms with their additional neutrons.
Okay. Well, we've investigated it. Now we know what happens if you get stuck into too much heavy water. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, I think we've got time for one quick question before we wrap up this episode. I think I promised two, but we'll get back to the other one in a later episode. But this one comes from Graham Gainsford, and this is a really good question and one worth investigating. Do galaxies inside a dark matter halo travel through time more slowly? Could this explain the expansion discrepancy in the expansion rate? As we sink into more dark matter over time, it would seem like the outside was speeding up. I think this is an awesome question. Please answer it. I think it's an awesome question too, Graham. Thank you for asking.
Yeah, actually, so do I. It is a good question because we know from general relativity that when you're in a gravitational field, you experience time dilation, so that anybody viewing from the outside would see time slowing down for you. And likewise, as you look from the inside out, you would see time speeding up on the outside. So it's a great question to postulate the fact that we're sitting within all galaxies, and that means the planets of stars are sitting within halos of dark matter. And the dark matter outweighs normal matter by 5 to 1. So I think the principle is correct that you're in a regime where there is time dilation taking place, but the bottom line here is that it's only microscopically slight, and that's because you're not experiencing a very high gravitational gradient on a black hole, for example, where the gravity is changing very rapidly with distance. Then you get these weird effects of time dilation, like somebody appears to be frozen on the event horizon because time seems to have stopped for them. But in a gradient like the one we experience with dark matter, that sort of phenomenon is not happening. So you've got a much lower level of time dilation that you're talking about, and I think that would. I haven't sat down and done the sums on this, but I don't think you could explain any of the questions about the expansion rate of the universe by postulating gravitational time dilation from inside the dark matter halo. I could be wrong, but that is my gut feeling, knowing about the way that dark matter behaves. But a very interesting thought, and I think Graham is to be congratulated on thinking outside the box like that. Very, very good. So he's right. It is an awesome question. I'm afraid we haven't really answered it properly, but we've done our best.
It's one that's been tackled in science fiction over many years, time dilation and speeding up and slowing down of time. I've mentioned before the movie Interstellar, which demonstrates the gravitational effect of a black hole on a planet that they visited, and they were within the effective radius of the gravitational effect. And so for every hour, I think, they spent on the planet's surface, the time on their spaceship had seen 7 years pass. And,
yes.
I think they were down on the planet for like 3 or 4 hours. So when they got back, the colleague on the spaceship was 20-something years older. And yep. It's mind-blowing. But what really blows my mind is that's not actually science fiction. In that scenario, it would really happen.
That's right, yeah. There were other issues with that, like you'd probably get spaghettified a bit by the strong gravitational.
Let's just let that one go.
Yeah. But no, that's right. It's real physics that you're talking about there, which is really quite good.
And they've done experiments on time using highly sensitive clocks. I think you and I talked about that. Yes. Those two clocks that they had perfectly synchronized, and they sent one to the top of a mountain or something, and when they checked them later, they were different.
Indeed, they were. That's right.
Time was travelling faster for one or slower for the other. I can't remember.
Slower the lower you are. The nearer the Earth's gravity you are, the slower your clocks are going.
Yeah, well, that explains my scholastic ability. Definitely. All right. And of course, we do thank you for your questions. We do get a lot of them, and sadly, I have to say we've reached a point where we have to be super choosy, and sometimes we will not get to them. But we are getting people who just send us notes, Fred, which is lovely. So they just send us notes to say, say hi or send us a photo or whatever, and we certainly encourage that. And we welcome all your input. We may not use a question on air or on the podcast, but we certainly do read them all. So bear that in mind. And occasionally we'll answer them just with an email if they're super boring. Oh no, super they're more easily explained that way. So bear that in mind. And I would also remind you of Patreon if you would like to become a subscriber to Space Nuts via our Patreon account, patreon.com/Space Nuts. And you will find us these days on YouTube and just about every other podcast platform. So looking forward to offering you our next episode very, very soon. Fred, as always, thank you. It's been a pleasure.
And a pleasure to talk to you too, Andrew. Thank you very much for having me on the show.
Oh, look, couldn't do it without you, really. We'll see you next time.
Yeah, see you next time.
Professor Fred Watson, half the team, actually probably 75% of the team here on Space Nuts. And from me, Andrew Dunkley, thank you as always. We'll catch you again next week.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.